reviewing for the probability test. There's lots of kinds of problems on the test. Ooh, weird, it highlighted a couple things that aren't even there. Here are some marbles, and my marbles, there are 10 of them, give me my problem on probability. What is the probability that I'd pick 2 reds and 1 black when I grab 3 marbles? Well, we've learned a lot of ways to find probabilities. We could make a tree. We could make a tree for almost every probability, and that's important to understand. But a tree on this one would be complicated. It would have a lot of parts. Just think for a second. For drawing out these marbles, what are the 3 things that could happen? Red, black, purple. Red, black, or purple. Okay, and then each of those has a probability. And then if we were going to keep going, after I got a red, I could get another red, or I could get a black, or I could get a purple. And then if I got 2 reds, I could get another red or black or purple. And this would be a complicated tree. Now, it still would work, though. One kid brought up a good point. They said, you couldn't even get 3 blacks. Like, you couldn't get black, 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 because there's only 2 blacks. Same thing with purples. So that's true, but all that means is when you are at the probability part of the tree where you're supposed to be drawing your 3rd black one, what's the probability of that? 0. So then when you're multiplying on the tree, you just end up with a 0 there at the end, because that is not possible to get black, black, black. Okay, so it still works. So trees are powerful, but they're kind of a pain. So I'm going to say on this problem, I would look for another way to do it that wasn't a tree. Any suggestions? Yes? With a C, yeah, with this combinations, okay? Do it with a combination. Do the bottom first, that's the easy part. Yeah, just tell me what to do. We'll get them started. There's 10. 10, and I'm going to choose out 3. I'm grabbing 3 marbles. So finish from there. I'll pause while you finish. Okay, 6C2 on the top. What did that represent? The purple ones, the red ones, the blue ones? What are they? There aren't any blue ones, I guess. Red ones, yes, there's 6 red ones, and I'm going to choose 2 of them. That's from this. And what was the other one? 2C1 of the black ones. There are 2, and I want 1 of them. Now, if you're an astute student, you might notice that this does not balance like it's supposed to. Something must be wrong then or missing. Yes?
I added in 4C.
Because there were, now, okay, I think you were thinking 2C0 because 2C0 is telling me about the purple ones and we never mentioned them, right? So there were 2 purples and I'm going to choose 0 of them. Now why does that help? Because now it adds up to what? 10, just like it's supposed to. This would have still added up to 3 even without the 0, but it still works. Really smart to check those problems by making sure they balanced. Raise your hand if you had that one right. Okay, good. Yes? I would not take off points if you didn't have this 2C0 part. But it would also be true that you wouldn't have been able to check yourself and check these like little green circles here. You wouldn't have been able to check to see if it balanced without doing that 2C0 part. Okay, next part. Try that one. This is eyeballs. What am I talking about? Well, you can make a marble have pretty much anything inside of it. You just have to like cover. They cover over the different various items with this clear plastic or a clear glass, and then you can have like a fish eyeball inside a marble. Yay! Okay, so you've got a total of 6 of these things, and there's 2 fish eyeballs, marbles, in with the other 4 blue marbles. Find the probability of an eyeball and a blue. And I'm going to just see which way you use. There's multiple ways you could solve this problem. Just to clarify, it does say that there's no replacement, meaning once I pick out let's say an eyeball marble, I don't put it back in, and I do the next problem. The probability of getting an eyeball and a blue one, and notice it says the order doesn't matter. I'll pause while you finish. So I'm curious, how many have made a first attempt at some way and it did not work? It wasn't making sense. As many of you tried something, and that's good. That means you, okay, I realize that didn't work, so now I can try something else. Who found a way that they think is working? Okay, tell me what that way is. What are you doing? Okay, you're multiplying fractions together, all right. That's a lot like what other technique where you would end up multiplying fractions together? A tree, yes. It's basically like a tree except without drawing the tree. All right, I'm going to pause again while you finish up. Okay, if I'm going with a tree, I'm going to start with probability of getting an eyeball marble is 2 out of 6, so you could reduce that to 1/3. The probability of getting a blue marble is 4 out of 6. Okay, now after, notice it says that there's not any replacement, so I'm not going to have 6 marbles the second time I draw. There's only going to be 5 marbles the second time I draw. So it's going to be eyeball marbles. If I got an eyeball marble here, that means that I only have 1 left out of 5. And if I got an eyeball marble here, then that means that I must have still got 4 blue ones left. Just trying to talk you through how I would be thinking about it. If I got a blue marble going this way on the tree, then that means there's less blue marbles. There's only 3 blue marbles left out of 5. And the eyeball marbles are still 2 out of 5. And when I actually multiply this out, I'm going to move this over for a second. I end up with EE. I'm going to pause while I finish this part. Okay, so now we've got everything on our tree that's possible. That means all of these added up together would have to add up to what? 1. So now, if I want to do eyeball and blue and the order doesn't matter, does this work for eyeball and blue? Yeah. And does this one also work? Yeah. So if you had 2, 6, 7, you forgot that there were 2 2, 6, 7s, and you have to put them together. Grand total when you add them up, 5, 3, what? 4. Thank you. Raise your hand if you had that one right. Okay, it's about 2/3 of the class. And this one, probability with at least 1 eyeball, that means this or this or this work. All 3 of them work. So I can either add those 3 up, or I can say, well, I know that they must add up to what? Because I look at that, that's this 0.4. These 3 must be 0.6 altogether. So 0.6 is the fast way. Otherwise, just add them up on your calculator, and yes, technically it would add up to 0.601, but don't worry about that thousandth. That's just a rounding thing. Okay? Raise your hand if you had 0.6 or 0.601. Okay, good. How many of you noticed this part about how you could just take 1 minus the 0.4? All right, good. A bunch of you did. Because that'll save you a lot of time on the test. I think there's one on there where you might have to like have 8 different branches on the tree, and either you have to add all 7 up, like at least 1 would mean like only thing that would not count as 0. You'd have to either add 7 things up, or you can just know this little trick of taking 1 minus that number. Okay. All right, let's try another one. That is just kind of a simple little binomial that's partway done. The little red question marks are things you could figure out. It's like somebody did half the problem and then quit because they were getting stuck. Who can talk me through one of those question marks where I know this one's got to be this? Bowman. This one. Yep. Because why? Yes, these have to add up to 1. Okay, what else do you know? Heidi. Yep. That's got to go there. Excellent. Okay. And Marissa. This one has to be 3 because these have to add up to 5. Very good. All right. So my point on that is that you can even be partway done with the problem and figure out all the rest just by using the math of it. you don't have to just like know all the answers right from the start.